Hello and welcome to my math companion. In this video, we will be looking at a more complex problem involving quadratic equations and their factorization. So let's begin. So we are told to factorize 3x squared plus 16x plus 5 is equal to -8 and solve for x. As in any quadratic equations problem, you must first write your equation in the form of ax squared plus bx plus c is equal to 0, which means that on the right hand side, you must not have any x terms or any constant term. It must be 0. So you must take this -8 to the left hand side of the equation, and you will do that by adding 8 to both sides of the equation. So when you do that, on the left hand side, you'll be left with 3x squared plus 16x plus 5 plus 8, which is 13. And on the right hand side, you'll get 0. So now we are ready to solve the equation by factorization. So first, let's define our coefficients. A, which is the coefficient of x squared, is 3. The coefficient of x is 16. And the constant term is 13. So in any factorization problem, your goal is to find two numbers k and m such that k times m is equal to a times c and k plus m is equal to b. Now you may think there are 5 different variables I have to find. Don't worry, you already know the values of a, c and b. So you just have to find two variables that are k and m. So we input the values of a, c and b into these two equations, and we get k times m is 3 times 13, which is 39. So we need to find two numbers k and m that when they're multiplied together gives us 39, and k plus m is 16, which is the value of b. So first, you must always try and solve for k times m, since there are much more limited number of values for k times m than k plus m, which means that the number of values for k times m is much lesser than k plus m. So 39 has only 4 factors, which are 1, 3, 13 and 39. So the first combination that we can try is k times m is equal to 1 times 39. But if we do that, then we'll get k plus m's value to be 1 plus 39, which is 40. And we see that k plus m must be equal to 16. So now we'll try 3 times 13 for k times m, and that will also give us 39. And now when we evaluate k plus m, we'll get k plus m to be 3 plus 13, which will give us 16. So k and m are 3 and 13. So now what we have to do is we have to split this middle term, that is bx or 16x, into kx plus mx, which means that in our case we must split 16x into 13x plus 3x, because 3 and 13 are k and m. So now we'll rewrite our equation as 3x squared plus 3x plus 13x plus 13 is equal to 0. Now note that it does not matter in which order you write 3x plus 13x, since multiplication and addition are both associative, and you will be using both in the you will be using multiplication and addition in the next few steps. So it does not matter which order you put them in. Now what we'll do is we will take the first two terms, which are 3x squared and 3x, and we will factor out any factors. So 3x squared plus 3x has a highest common factor of 3x, which means that if we divide both of these numbers, 3x squared and 3x, if we divide both of them by 3x, we will get two numbers that are relatively prime. So 3x squared plus 3x, we can factor out 3x, and we can write 3x times x plus 1, since 3x times x is 3x squared and 3x times 1 is 3x. So just by doing a normal binomial expansion, you will get back this original term. Next, we'll take the last two terms and factor out any factors, or we will factor out the highest common factor. So in 13x plus 13, there is no x term in this last 13, so we cannot factor out any x, but we can factor out 13 because 13 is there in both of these terms. So we will factor out 13, which is the highest common factor, and write 13 times x plus 1. Again, if you expand this binomial, you will get 13 times x, which is 13x, plus 13, which is the same thing as this term right over here. So now we'll rewrite our equation again. So 3x squared plus 3x can be written as 3x into x plus 1, and 13x plus 13 can be written as 13 times x plus 1, and the whole thing is equal to 0. So now you might see that x plus 1 is there in both of these terms, and when you have a form like this, you can take the 3x and 13 and add the two of them and multiply that binomial by x plus 1. And you will get the logic behind this if you were to expand this binomial back again. If you were to expand this binomial, you would first multiply x with 3x, and that would give you 3x squared, which is there here. Then you would multiply x with 13, which would give you 13x. And then you would multiply 1 with 3x, which would give you 3x over here. And then you would multiply 1 with 13, which would give you 13 over here. And therefore, we now have to solve for x. So in order to solve for x, we need to make sure that either one of these two binomial terms is equal to 0. So for the entire product to be 0, at least one of these two binomials must be 0. And therefore, we can consider the case when each of them is 0 and take the value of x for that. So if we consider x plus 1 to be 0, then we will have x plus 1 is equal to 0, and thus x equal to negative 1, since we are subtracting 1 from both sides. Next, we will let 3x plus 13 be equal to 0, and in this case, we will subtract 13 from both sides of the equation to isolate 3x, and then we will divide both sides of the equation by 3 to isolate x, and we'll get x to be negative 13 by 3. And so, our two values of x are negative 1 and negative 13 by 3. So that is how you solve a quadratic equation by factorization. Do join us in the next video, which will involve a more complex example involving factorization.